Welcome to the Basic Foundation lecture series. This is our lecture number 5, and in this lecture we are going to learn about Newton's laws of motion. The topics that we are going to cover in this lecture are force, Newton's first law, Newton's second law, and Newton's third law. Let us begin with the definition of force. So force is a physical quantity which can change state of rest, state of uniform motion, direction of motion, and size or shape of the object. It is a vector quantity and SI unit of force is kg meter per second square or Newton. In other words, we can say that to change state of rest of any object, we need a force or set of forces. To change state of uniform motion, we have already discussed that if a body is moving with constant velocity, then it is said to be moving in a uniform motion. So to change its state of uniform motion, we need a force or set of forces. To change direction of motion, a force is needed or set of forces are needed. And to deform a body or to change shape of the body, a force is needed or set of forces are needed. After learning the definition of force, we can easily understand Newton's first law, which states that a body at rest will remain at rest and a body in uniform motion will remain in uniform motion until or unless it is acted upon by an unbalanced force. This law is also known as law of inertia. So if a body is at rest, then it will remain at rest until and unless it is acted upon by an external force. And if a body is moving in a uniform motion, which implies that velocity of body remains constant, that is magnitude as well as direction of the body should remain constant. So this body will move with this constant velocity for as long as it is acted upon by an external unbalanced force. Now we are going to discuss a very important concept which is known as inertia. So inertia is a property of an object any object by virtue of which it opposes any change. So there are three types of inertia that we have to study. First one is inertia of rest, second one is inertia of motion, and third one is inertia of direction. So the tendency of body to continue in a state of rest is known as inertia of rest. The tendency of body to continue in its state of motion is called inertia of motion, and the tendency of a body to oppose any change in its direction of motion is known as inertia of direction. So inertia of rest is tendency of any object to continue its state of rest inertia of motion is tendency of any object to continue its state of motion, and inertia of direction is tendency of any object to oppose any change in its direction. We will now move on to Newton's second law, which states that the rate of change in momentum of a body is directly proportional to the applied unbalanced forces. So rate of change in momentum is directly proportional to external forces applied. Later on, it was found that the proportionality constant for this equation is equal to unity. So external forces applied on any object is equal to rate of change in momentum, that is change in momentum upon time interval. If you don't know what does momentum mean, so momentum is the product of mass of the object and velocity of the object. Since velocity is a vector quantity and mass is a scalar quantity, so momentum is also a vector quantity, because if we multiply a vector quantity by a scalar, then we get a vector quantity, and SI unit of vector is SI unit of momentum is kg meter per second. So according to second law of motion, external force is equal to rate of change in momentum, and we now know that momentum is equal to mass into velocity, and if mass of the system remains constant, then we can write this equation as m into delta v by delta t, and we know that change in velocity per unit time is nothing but acceleration of the object. So from this equation we can say that force is equal to mass of the object into acceleration of the object. We'll now move on to Newton's third law, which states that for every action there is equal and opposite reaction. In this statement, action and reaction means nothing else but forces. So we can say that forces always exist in pairs. So forces always exist in pairs, and what does it mean? It means that if, if body A applies force F on body B, then body B will apply the force which has the same magnitude, but direction of this force will be opposite to this force F. One of the most important concepts that we have to keep in our mind is that action and reaction never balance each other, because they act on two different bodies. In this example, this force F is being applied by body A on body B, and in reaction, body B is applying the force having same magnitude but opposite direction to body A. So these two forces are acting on two different bodies, so they will not balance each other. We will now solve some examples based on the concepts that we have discussed. So in this example, we have to find a force which can change velocity of a body of mass 2 kg from 20 meter per second to 30 meter per second in 2 seconds. So from second law of motion, we can say that force is equal to mass into acceleration, and we know the mass of body is 2 kg and acceleration is nothing but change in velocity per unit time. So required force will be equal to mass into final velocity minus initial velocity upon time, and the required force will then be equal to 10 newtons. We can also find acceleration by using equation of kinematics, which is nothing but v is equal to u plus at, and final velocity of this object is 30, initial velocity is 20, and time taken is 2 seconds. So from this we will also get acceleration a is equal to 30 minus 20 by 2 meter per second square. In the next example, a person of mass 100 kg is applying a force of 10 Newton on another person of mass 50 kg, and we have to find the magnitude of force exerted by the second person on the first person. The answer is clearly 10 Newton, because from Newton's third law of motion, we can say that for every action there is an equal and opposite reaction. So magnitude of force exerted by the second person on the first person will be same as the magnitude of force exerted by first person on the second person. I hope this video was helpful for you. Thank you so much.